Before I started, I just wanted to ask are y'all's experiences with Node or with JavaScript? Does everyone here have a passing familiarity with JavaScript? Hands up if you've used JavaScript before. Okay, cool. I think that's good. And how many of you have played around with Node before at all?
A little bit.
Okay, good. Yeah, because what we're going to try and do is start with fairly basic concepts, like what is Node, what is an event loop, what is event-driven I/O, and start from there, and also going over some JavaScript basics for those of you that haven't played around with it as much. And then we'll go through deployment and things like that. But I'll just be covering the first section, like the basics of Node, JavaScript, etc. And before I start, I'm Helen Zhang, and I work in San Francisco with a lot of startups to do startup developer evangelism. So what that means is I'll work with startups that are working with Microsoft products or with Microsoft platforms like Windows 8, Windows Phone, if they're doing any sort of deployment on Azure, and I'll help them generally along that process. So in that vein, if that's something that you guys were interested in, if, for example, you work at a startup, you have your own startup, and you're interested in Azure, Windows 8 or something, come talk to me afterwards. Okay. Oh, and of course, all the information that we'll be presenting will be on my GitHub account. So that's just DPE-WR if you wanted to go look at that later. Okay. So first, I just wanted to talk briefly about Node and what is Node, how does it work, etc. So Node was developed in 2009 by Ryan Dahl, and right now it's managed and handled by Joyent, which is his employer at the time. So people have been using JavaScript for years and years and years, and you guys have some familiarity with JavaScript. But it's primarily been in the browser, doing small animations like pop-ups, opening things up in a new window, etc., etc. And as of recently, it's been getting a lot better, right? We have libraries like jQuery that enable you to do so many more things with JavaScript. And there's been attempts in the past to do something like Node where you have JavaScript on the back end, but they've traditionally gone the route of making JavaScript like an MVC framework, like Ruby on Rails or Sinatra or Django. And that hasn't really worked out as much. So Node is different in that it doesn't try to give you an MVC framework, for example. In order to, for example, make a full-scale site, you might use something like Express, which I think we're using today. And Node's really unique in that it is a very evented model. So, for example, you wouldn't really be using, you wouldn't be spawning off threads or new processes to deal with different things. You'd only be, you'd be more focused on things like events and callbacks, so that if you need something to be done, you just spin off that and it'll do its processing and it'll have a callback. And you can continue on what you're doing before. So that's what we tend to call event blocking, or non-blocking. And that really encourages good asynchronous programming habits. And it's, I think, an easier way of programming, really, because the code that you're writing is, for the most part, from top to bottom, and you don't have to think about spawning those new processes because Node abstracts a lot of that away for you. Okay, so can you guys read this, by the way? You don't necessarily need to. Okay. So first of all, let's talk about how does Node run. So Node runs in its own system process, and it listens to different HTTP requests on a port that you specify. And we'll be looking at an example hello world in a little bit. And when there's a request, or when anything really alerts the event loop, the OS kind of wakes up Node and it decides what to do with that specific event or with that specific request. So for example, if you're making a request, Node's like, oh, okay, you're giving me a request, that's great. It'll usually be spun off on a worker thread. So for example, if you're reading from a database, or if you're doing some intensive application logic, that'll typically be spun off. And after it's finished, the worker will call back to the event loop, and it'll give it a response. And then that response will be used to parse whatever was needed before. So what powers Node? Node runs off of Google Chrome's V8 JavaScript engine, which is what Chrome uses to render most of JavaScript there. So that's similar to, for example, what Internet Explorer. So Internet Explorer also has another one. I think we call it Trident. Yeah. And basically, every browser has something that parses JavaScript, but Google Chrome's V8 engine is extremely fast, and now because Node uses that to process all of that JavaScript, it runs at speeds that are about as fast as Ruby or Python in some cases. Another thing that Node uses is the common JS module system. So we'll be talking later about the Node package manager, NPM, and that's what lets you define different modules, so different plugins that you can add to your Node application. And also use packages that have been created before by other developers. And the final component is libev or libev, which is developed by Joint, and that's what processes that event loop that we've been talking about so much. And it also processes incoming network connections. And so if you wanted to find out more about kind of history of Node, or more of a beginner's introduction to Node, the Node Beginner ebook is actually really good, and we have a link to that as well. Okay, and now I want to talk in a little bit more detail about the event loop, which is probably, if you're not familiar with Node or event-driven development, it's probably the most confusing part of Node. So one really good analogy I've heard about this is just everyday life, because we tend to work kind of like an event loop. So for example, if you're in the kitchen and you're cooking something, you might already have some water boiling on. You might put some water on the stove and wait for that to boil. And while you're waiting for that to boil, you're chopping up some vegetables. But then the water starts boiling, and oh my gosh, you need to do something. So that kind of sends alert to you as the event loop, and you go and you take care. You finish chopping up maybe like the pepper or the tomato that you're chopping up. You go over to the water. You add seasoning, add whatever you need to add, and then you go back to doing what you're doing. And that's really similar in the way that the event loop works, in that there's some alert that's sent up to you, and then you go and do that, and then you return the process you're doing. But for the most part, you're doing things in a single sequence. And so that's kind of the way that you code in JavaScript for Node. So it's an easier paradigm to think about. So in that case, Node is a single-threaded Node is single-threaded, and the way that you would So for example, there's some code here that just is very simple, and it's the canonical hello world for Node. And what that does is it creates a server, and it starts listening to it. And so because Node is single-threaded, after you create the server, it'll start listening on that port. And that just starts executing and listening for different events that happen. And any request that comes into it will execute on what we call a green thread, which is basically a thread that executes on like a virtual machine for that. And so this is a graphic that sort of illustrates what that processing looks like. So you can see that in the middle here, there's an event loop that that continuously runs. And if there are any client requests that happen from any clients, it'll come into event loop. We'll quickly process whatever requests are necessary, and then it'll return the results to the client. And if there are larger operations that you need to do, like database queries, for example, that typically gets handed off to a worker role. It runs, and those tend to be like longer running processes. So that'll go on for a while, and once it's done, it sends its response back to the event loop. But in the meantime, the event loop just keeps going and processing whatever alerts it, whatever responses or requests alert it. And so there are a couple of advantages to this model. And the main one is that because the event loop just uses a single thread and small allocation memory to handle a bunch of concurrent connections, it makes Node extremely fast, and it makes the relative overhead to the number of connections grow relatively slowly. So that's why Node is really good for applications like, for example, chat servers or anything that requires a lot of connection that way. And another thing is that because all the long-running tasks that you have to do, like network I/O things or data access things, are executed asynchronously, and the results are only called back when it's done, so it's non-blocking. This forces a lot of Node applications to work. It forces you into the habit of developing for asynchronous applications, basically. And because it means heavily reliant on JavaScript, and JavaScript has many features like being able to pass functions around its objects, for example, or having closures. This works really well with Node's programming model, so that it's easier to manage. So you don't have to manage different threads. You can spin off different executions of like different functions and come back. So that eliminates a lot of the pitfalls, for example, that you might fall into when you're developing a current application. Okay. And next, we want to talk about the history of JavaScript and Node and how they work together. So JavaScript was developed way back in 1995, and like we talked about, JavaScript was originally used for like very relatively mundane things, like pop-ups or menus or things like that, and it wasn't really taken seriously as a language. But starting in about 2000, JavaScript was used more seriously to like load data on a web page, like using Ajax, for example, and that's when JavaScript started being able to do more heavy lifting. And in 2008, after Google released Chrome, and JavaScript was taken much more seriously because the performance increased drastically, and it sort of forced a lot of major browsers like Internet Explorer or Firefox to iterate more quickly on being able to, on its JavaScript execution. So now that JavaScript is so much more powerful and so much more performant, it's converted a lot of previous JavaScript developers into thinking that maybe JavaScript is like a real programming language. It's not just a toy anymore. It can do so many things, like, for example, being used on the back end. So,
question?
Yeah.
Why does Node.js just run on Chrome engine and not Scrollfish, TraceMonkey, and Chakra?
It's not so much that it was built on top of Chrome's V8 engine, and it uses that to process what the JavaScript that's given to it. So it was built using that code. I mean, at least partially because it's open
Is there
source.
any reason that you couldn't create a Node API on top of Chopper?
Perhaps not, but it's just the way that it's been built before, and at the time V8 was like much faster, quite honestly, than any of the other JavaScript rendering engines.
There is a very good video by Ryan Dahl. Watch that video on YouTube, Intro to Node. And it's not like Node is tapping into a JavaScript engine to run. It's built with V8 in it to run as an executable wrapped in Node.
Yeah.
It's not talking to Chakra, it's not talking to our Chakra, it's not talking to any other JavaScript engine. It is built with V8 engine in it.
Yeah. And so at the time, he made the choice to use the V8 engine. Other questions? And lastly, we wanted to go over a quick overview of JavaScript. I know from asking that a lot of you are already familiar with JavaScript, but because there are some of you that didn't raise your hands and might not be as familiar, we'll just go over some quick JavaScript language features. So for example, what are variables in JavaScript? Well, you can declare them very simply with just var and then your variable name. And variable names can be anything, can have to start with a letter from A to Z, capital or non-capital, or an underscore, and then you can also add numbers to it as well. And they're dynamically typed, which means you don't have to declare a type to it like you might do in Java. So you don't have to declare it as an integer or anything else. So in this example, we first declared x as 5, and then even if you change it, and you can also then redefine it to 7 as a string, and that's fine too, because you don't have to tell JavaScript what type it is, and you can change things around dynamically like that. And there's some built-in types in JavaScript that JavaScript will automatically recognize for you. So there are things like integers, like floating point numbers, booleans, strings, and arrays. Another interesting thing is how functions work in JavaScript. So you declare them just with function, and then the function name. So for example, this is fake math function, and then you can write what parameters it takes in. So this one takes in two parameters, and in this case, I mean, what you're looking for implicitly is that these two are both numbers, because but again, this is not something that you can actually tell JavaScript. But in this function, you can, for example, increase the value of A. You can increase the value of B by adding 3 to it, and you can return the result of it. These instance variables. You can also, and now that you've declared fake math function, you can also. What's interesting about JavaScript is that you can use functions as you would an object. So for example, you can do things like this. You can define fmf as fake math function, and then you can use fmf as its own thing. So for example, now it's declaring variable d and then using fmf with the input 5 and 6, and the result of that will be passed back into D. And you can also pass functions into other functions, for example. And you can even pass functions anonymously. So that's where you're declaring a function, but you're not giving it a name. So let's talk also about some of the control flow features in JavaScript. So that's things like if and else and while. And Basically, it'll take in a Boolean, and if or it'll take in a variable, and if it's a relatively truthy variable, it'll go in the loop, and otherwise it'll fall out. So, so truthy variables are obviously things like true. It's also something like for instance, integer 1 or string. But if but things that won't work would be, for instance, if you pass in a 0. And so there are different control flow patterns that you might be familiar with that exist in JavaScript. So there's if, there's else if, there's while, there's do while loops, and there are for loops.
Sorry, can you zoom in? I think
Yeah.
it'd be easier to see.
Is that good?
Yeah, I think it's better.
Okay, great. And objects in JavaScript are fairly special as variables. So, for example, you can create a new object. You can create an object by using keyword new on a function, and you can use this keyword to reference properties that explicitly reference function, properties that are inside that. So you see here, you have function here, and then when you use this, it's within the scope of this function, and you can declare things like ID or name for that, of that object. So here now you're declaring a new variable, my new customer, and you're making that an instance of the customer object, and it'll have parameters like ID and name, which the customer object does. And you can also instantiate them this way, by, for example, declaring object and then just passing in the ID as sort of dictionary objects. And technically, you can't have classes in JavaScript like you would in Java or C, but you can add methods or objects, and you by making them parameters, because functions can be like objects in JavaScript. So, for example, here you have hello as a function, and you're just making that a parameter, and you're declaring that function as this. So now when you use it again, you can just, so now when you call hello for something else, it'll just return, if you're declaring, for example, a new foo, and you call on that, and you call it, for example, like test, then if you do test.hello, it'll return its greeting. So because objects are pretty flexible in JavaScript, you can do a bunch of different interesting things with it. And this kind of encompasses all the things that we've been talking about before, in that you can create a new object that's completely empty and add different properties to it, like a name or a method or function that it has. And you can even loop through its different properties by using a for-in loop like this, which is basically like an easy way of doing a for loop, where it iterates through the parameters of the object that you're passing in. So and arrays are a built-in object type that's in JavaScript that we talked about before. It's one of the basic types that JavaScript supports. So using that, you can store like multiple objects of various types within a single object. So here you see that we, for instance, instance declared a new array, and you can declare an empty array like that. Or you can declare an empty array and instantiate it with different elements. And they don't have to be the same type, so you can, for instance, put in integers and strings in the same one, or even integers, booleans, floats, strings, and other objects. And you can access them by just calling the index element like that. You can also declare and you don't have to declare an index for them, but and the index of the element doesn't necessarily have to be an integer. You can also use a string, for example, so more like a dictionary than anything else. So that if you call, for example, you can say the wow element in my array is we, and now if you set text to whatever my array at index wow is, you'll get we returned to you. And you can use, and for arrays you can also use for in loops, like we talked about before. And one of the things that we had said a lot was that Node.js uses Event.io, it uses a lot of callbacks. And so this is an example of what that might look like. So for example, so you're passing in like 2 parameters, and then you're passing in callback, which is the function that will be called after this big math function executes. So you'll do what you did before, which is increasing the value of A, setting the value of b to b plus 3, and then multiplying them together. And then after all that executes, because you're passing in a function, you're passing in a callback function into the fake math function, and it's one of the parameters, you can now call that with whatever you did in the function itself. And that basically ensures that it executes after what you're doing in fake math function. So you would do that, for instance, like this, where you're passing in 2 parameters, A and B, and then this function will be the callback function. And it's one that you're declaring right here, where all it does is basically in the console, it'll say callback. It'll give you the value of num from here. So basically the value of C, because that's what the call function is. Yeah. So does anyone have questions about JavaScript in general, not just the basics that I covered here? Okay, awesome. And why don't you go over some specifics of JavaScript in relation to...
You're not going to cover filters?
No, because I looked at that and it seems very...
Okay, about 50% of books written on JavaScript don't cover filters either.
Yeah. I think it's a difficult concept to explain to someone unless you have a lot of time. So I just want to skip over that for now and talk about JavaScript for Node.js. So it's interesting because usually we use JavaScript in the browser, so you have things like window or document that we typically do. That we would typically use, but that's not what Node.js is, right? It's not in the client, there's no DOM, so you have to think about, you have to basically think about JavaScript in a different way. You're not, it's not client-side code, yes?
There's no link to this?
Yeah,
I'll
it's...
sign up later. I'll sign up.
Well, I just want to read along.
It's up here. So it's just github.com/dpe-wr/node-bootcamp.
I'll send out to you the same group that I did 2 days ago. Send it via email.
Yeah. Yeah, I can't see, I can't read it.
Okay, I'll set it up.
Okay, great.
So because Node is wholly different, it uses various different modules. So for example, HTTP or URL are different modules, and you add them by basically declaring them. Just like you can declare the port, for example, which is more of a platform-specific thing. So this basically determines the port to listen on. And this again is the canonical like hello world for Node, basically, where you declare your own server, where you create your own server. And if you look at it, actually it's just a couple of functions with a lot of commented code. So here you're adding the module HTTP, and you're adding URL and your okay. And you're finding the port. Then this entire function just basically creates a server for you. So it passes an anonymous function where you have your request and your response. And in the response, which is basically just the page that you're creating, you're declaring the content type, which is just text, and at the end of that, you're writing a hello world. And then after that finishes, you're doing, and after that, you continue to listen in on that port. So, for example, so that's just basically what happened there. You're declaring HTTP, you're creating a server.
Sorry, can you zoom in? Can you also enlarge the window?
Yeah, we'll do.
Okay.
So these are just a couple of lines, but this is all it takes to just get that server up and running and have it say hello world. So I'm listening in on port 8000, and all I'm doing is I'm also adding in console.log at the end, so that once it starts running, it just tells you what's going to happen. So, and I just have this as like one small JavaScript file here, and I just open a command window here. All I say is node server.js, and it's now running. It's at the end of that, and I can even show you it running here. So now if I go to localhost at 8000, and so now I just go to port 8000, and we can see it does indeed say hello world, like we asked it to. Okay, questions?
Oh, does the console log show in the terminal?
Yeah,
Okay.
it does.
How would you execute this from the Sublime editor?
I think execute.
So it's,
Like what you showed was the Sublime editor, right? Can you execute it from there?
can I execute from here?
Yeah.
I don't think so. Typically, you would just then use whatever command line interface to execute what you just wrote here. And if you're running a Mac, you would just open up terminal and run that as well. So, yeah. Fairly simple, very lightweight to get started on Node. As you can see here, it's a couple lines of code. I even added an extra line for console.log, and it's already running. So
yes. How many threads is it used to produce this result? We don't have here any asynchronous operation.
Pardon?
We don't have any asynchronous operation here. So how many threads is required to produce the result?
One, because Node is always running single thread.
Like before, you told that it's Node.js is single-threaded. So if I have two requests at the same time, will the first request have to finish before the second will start the processing, or they will do both in
Do
parallel?
both.
Yeah, they do.
Theoretically, that's both.
Yeah, because you have that one thread running and you'll make two requests to the event loop, right? But they'll both spin off and run that without blocking.
So if this request was made synchronously by multiple browsers, how would it work in that case?
Okay, let me pull back up the event loop picture. I think that would, only I could find my mouse.
No, I mean technically behind the scene. I know the results will come up, but what would happen behind the scene if multiple concurrent requests would go through at the same time?
So every time a request is made to it, it'll wake up like the event loop, and
If multiple requests are made, will it block the other ones?
no. So basically the only thing that gets sent in is like the request, and then and it'll spin off like a virtual thread basically that. Yeah, so you can have like various different clients make requests, and every time a request is made, it'll send like a response back. Yeah.
Wait, so only one instance of the response callback is running, right? At any time.
What do you mean by that?
So like I know there's like the event thing, like but when callback is called, like the callback function, like no two instances, like assume you're writing to a file inside the callback. There's no race condition, right? Like one callback is gonna execute to the end, and then the other guy will do.
So everything that, okay. So I think that I didn't make that initially clear enough. So your code is basically, so everything in Node basically will run in parallel except like the code that you wrote. Does that make sense? So if you're doing different things like serving a request to someone, those can be run in parallel, and like as many of those and so on as you want. But in terms of like what will happen in your code, that runs in sequence. Yes.
Okay.
So does this replace IIS, or how does, like, we have a web application, right, which is hosted on II. So where does Node.js live? It has to be hosted as a separate component in the IIS, or how?
Yeah, it's a web server. That few lines that you see up there, the hello world.
Okay.
Technically, there's just two lines. First line is a var. Second line is http.createServer. You're actually creating a web server in one line of code.
So then the IIS won't be running? Like in production environment, how does it work? We cannot run it as a console, right?
Yeah, the node executable is in your server. It runs outside of IIS. It runs independently. And every time incoming request comes in, it spins up another instance of it.
So let's say I have an ASP.NET application. So how does the two marry together? Or is it these are separate components?
As far as I understand, they will run separately. You need to talk to each other. That's another layer. Eric, am I right?
Yeah, what I've seen, and actually what Azure does is it has IIS, and IIS essentially requests to the node process. So there are many private developers that are looking for IIS to make the two work together. So it's similar to how it does with other languages with what it has. But they're not, they do different things, I guess is the point. It's almost kind of more similar to Apache in Java, or something like that. At least that's my experience with how they work together. So for a server that, so Node, the event loop is single threaded. So I think it was alluded to with an earlier question is what request is service when you do work. You can continue to keep taking requests, but the event loop processes them in a single thread. So
Wait, sorry, just to make sure, like everything in your callback function is this like atomic? Are the two lines atomic? Like,
Which
if you're serving two users, like these two lines of code will only execute one after another for one user, and then do it for another user, or
Every time a request gets pinged to the server, it spins up, it calls this code. And if the same two requests comes in, it will spin up their own. So it's not blocking.
It's not?
That's the beauty of
okay,
concurrency.
okay.
Otherwise, everything will get blocked up. So
But then,
way I like
how
this-
is that single-threaded? Like, I thought, okay,
Yeah, we can get into a bit more of the technical stuff later on, onto the architecture and how it taps the
Okay,
processes. So the way I like to describe a node to beginners is think of it as when you go to McDonald's and you do the drive-through, right? If your fries are not ready, what do they tell you? To wait there? No, they tell you to pull forward, go to the parking lot. I'm not sure if they do it in California. I'm from Seattle. So they tell you pull forward to the parking lot and we'll send someone up there. And the reason they do that is because they can keep the cars moving. So as far as the operation is concerned, they are always moving. Although some stuff that needs more time is being packaged off to spin, but they keep their lines moving and moving, moving. And that's like a simplistic analogy of node. It just keeps moving. Asynchronous, pretty much I'm describing the asynchronous model. So if I don't have fries, no one has to wait. I have to wait, but the next person who comes in will keep spinning. So the convoy keeps going. Yeah.
Actually, according to my understanding, Node.js can completely replace Apache. So theoretically, Node.js can also replace all our functionality of IIS.
that doesn't make sense.
I can't comment on that. I do not enough that
One
deep
thing
of
is
a
that
technical
in our thread,
comparison.
control request,
Yeah, because
but the
our
work is not
also
done there.
running
There is a
Apache,
typo in the
and after
data.
using Node.js,
Well,
even
Sure.
Apache.
No, but what I'm asking is like, you see the callback, right?
So let me hand time back to Alan
Because
to wrap up.
it's single-threaded, JavaScript is single-threaded, so that callback has only one instance of the callback has to be running. You can't have two functions of the callback running at the same time, right?
So your question was still like, what happens with the callbacks?
Yeah, because like my main worry is like, say if you're writing to a file, like writing to a same file in the callback, like if you have two write operations in the callback, are there going to be interleaving between the two if you have two requests?
It depends on when the responses come back, basically.
Sure.
So you're spinning up different things, and then.
But if it's
like,
single-threaded, then there should be no interleavings, right? But for your explanation, there's going to be interleavings because apparently Node spins like two-thread or something.
Well, it's not. So if like two responses come back, they'll come back in some sort of order, right? So the first response will be, for example,
Okay.
written into the stream,
Okay.
and then the second response will be written
Okay.
into the stream. Is that the question?
Sort of. So there is no Okay.
Yeah.
Okay.
Sorry, I thought you meant like if there are multiple responses
No,
coming
okay.
back, will they be together?
Okay.
Yeah. Does that make sense?
Yeah.
Are there any other questions? If not, I think Felix is actually going to come up and talk about deploying this, how to write an actual web application beyond just having your server up and running and saying hello world. Okay. Great.
Thank you.
Thanks.